How's it going, guys? Today in this video, we're going to be going over day 2 of module 2. We're going to be kind of skipping around. We're going to be starting right here on module 2.1 on page 9. So let's go ahead and hopefully you have your notes open up to this page. We're going to go ahead and get started. I know there's a warm-up. If you want the keys, you can be on Canvas already. You can go and double-check your work there if you want to. We're going to jump right into the notes. So here, what we're trying to do is we have a graph of an absolute value function, and we want to take it and get our equation from that. So it's going to be very similar to how we did this in module 1. We're going to get our HK points from our vertex, and we're going to choose any other XY points on the graph as long as it's not the vertex itself, and we're going to use that to figure out whatever parameter we're looking for. So in this case, our H is 2, and our K is 5. The vertex is HK, and our XY point will be 6, 6. That's the point they gave us. That's the point we're going to use. And now we're going to plug everything in, and we're going to solve for B. So our G of X, or really just our Y, that's 6. That's going to equal the absolute value of 1 over B multiplied by our X of 6 minus our H of 2. Close the parentheses, plus 5. And now we're going to simplify this equation. We're going to minus 5 on both sides. We get 1 equals the absolute value of 1 over B. 6 minus 2 is 4. And we're going to close the absolute value. And I'm going to move this to the bottom here because I don't have much room. So 1 equals the absolute value of 1 over B. Multiplied by 4, close absolute value. And we're going to solve this now. So we have 1 equals 4 all over B, the absolute value of that. And from this point on, we have the absolute value, right? And we haven't really fully learned how to solve this yet. We're going to later in this video. But when it comes to figuring out the equation from a graph, when you have a variable in there like B, or especially just B, really, when you reflect over the y-axis, when it comes to absolute values, you're really not doing anything. When you flip it over the y-axis, it's just going to land right on top of itself again. It's going to be basically the same. It's going to be the same equation, whether b was positive, it was the same number, positive or negative. So what I'm trying to say here is that when it comes to b's, you can just go ahead and get rid of the absolute value sign, because if b was like -2 or +2, even if it was like one was positive, one was negative, it's going to get the same graph, because when you reflect over the y-axis, you're just landing right on top of yourself when it comes to absolute values anyway. So here, we're just going to get 1 equals 4 over b. We're just going to get rid of it. And we're going to multiply by b on both sides, because when we do that, those b's cancel out, right? 4 over b times b over 1, those b's cancel out. And we're left with b equals 4 over 1, or really just 4. So that's our b value. And they're just asking us for the equation. So we're going to take that b and plug it back in. So we get g of x. Remember, do not plug in your y and x points that you used back into your answer. So it's just g of x. We're not going to use 6. That's going to equal the absolute value of 1 over our b value of 4, multiplied by our x value, minus our h of 2, all plus 5. Let's go ahead and box this so we don't get confused. But that's what we get. All right. So the big thing here is really this absolute value part, going from here to here, knowing that reflections over the y-axis really aren't doing anything when it comes to absolute value functions. So you can just go ahead and just get rid of it. All right. So for number 2 and number 3, since we've already really just had a test about solving the function, the equation of the function from a graph, I think number 2 and number 3, now that you've seen how I've done it, you can do it yourself. So pause the video, try doing number 2 and number 3 on your own. If you're having trouble, just rewatch what I did here, or just go ahead in the video and see what I got from the answer. So if you haven't paused the video, go ahead and do it now. I'm going to go on to the next page, or the next slide, and show you the answer to number 2 first. So our HK point, remember, that's our vertex, which is 1, 6. xy, it's any other point on the graph that's not the vertex. So they give us 0, 3. That's what we're going to use. And we have xy and our hk, so we're going to plug that all in. And the big thing here, I think, is knowing that the absolute value of -1 is just 1, right? So from the very beginning right here, we have 3 equals a times the absolute value of 0 minus 1, all plus 6. We minus the 6 on both sides to give us this -3. And then -3 equals a times the absolute value of -1 is the same thing as just -3 equals a times 1. The absolute value of -1 is just 1. Remember, absolute values, if you have a negative number in there, they turn positive. If it's positive, it stays positive. If it's 0, it stays 0. All right, remember, the absolute value is telling you the distance of that number from 0. -1 is 1 unit away from 0. -2 will be 2 units away from 0. And +2 is still 2 units away from 0 as well. So absolute values, you want to think about it this way, they just turn everything that's negative into a positive. That's really all they do. All right, so that's why this -1 became a +1, and our a is just -3. And our equation will be this right here. All right, let's go on to number 3. This is what you should have gotten. Number 3 was a little more difficult. Math is a little harder. So our hk is still the vertex, -5, -1. Our xy point is still 0, 9. So we're going to plug everything in. We get this 9 equals the absolute value of 1 over b times 0 minus -5, which becomes 0 plus 5. Close the absolute value signs, all that minus 1. We added 1 to both sides to get this 10. That equals the absolute value of 1 over b times 5. 0 plus 5 is just 5. And that is going to give us, as an arrow right there, it's not the prettiest, that's telling us that 10 will equal 1 over b times 5. Like I said in the first example, that it really doesn't matter. Well, absolute values don't really do anything when it comes to solving for the b. So just take them off and just put it as 10 equals 1 over b times 5. And like I said, that's just because whether b is positive or negative, it doesn't really matter. You're going to be getting the same equation either way, or the same graph either way. All right. So you get 10 equals 1 over b times 5. What we did here on this line right here is I multiplied by b on both sides, so they canceled out, and I'm left with 10b equals 5. I divided by 10 on both sides to get to keep that b by itself. So b equals 5 over 10, or just 1/2. So we ended with b equals 1/2. We take that b, remember it's 1 over 1/2. So you just flip the b, and that gives you this equation right there. G of x equals the absolute value of 2 times x plus 5, all minus 1. And that's your final answer. All right? So from here, like I said, we are going to be skipping around a bit on 2.1. Oh, 2.1 and 2.2, we're kind of skipping around a bit. So here, we're not going to do page 10 in your notes. We're going to skip on to page 11, the first day of 2.2. And we're going to do this, we're going to just start with the notes here, all right? We might come back to those word problems later on, but for now, we're going to teach you guys how to solve absolute value equations using a graph and algebraic. So absolute value equations can have 2 solutions, right? Like the absolute value of -2 and absolute value of 2 both give you the same number of 2. So write your answer. So we're writing our answer. We're going to write it as a disjunction. And a disjunction really is just a really fancy way of just saying or, right? If your answer is -2 and 2, our disjunction will be our answer is x equals -2 or x equals 2. Saying one or the other. That's what a disjunction is. It's really just a fancy way of saying or. All right. So we're going to learn how to solve our absolute value functions using graphs. And what we're going to do is, like for number 1, we're going to treat both sides of this equal sign as 2 different equations. So we're going to graph 2 times absolute value of x plus 2 minus 3 as its own equation. And then we're going to graph y equals 1 as its own equation as well. And once we do that, what we're going to do is we're going to see where they intersect. And where they intersect, that's going to be our solutions. So for instance, on number 1, we're going to graph that 2 times absolute value of x plus 2 minus 3 first. And I'm actually going to teach you guys a little trick for graphing absolute value functions much faster when you do not have a b. All right. So here what we're going to do is we're going to go to our vertex first. Remember, it's our hk. So in this case, -2, -3. Remember, we flipped the sign since it's x minus h. So x minus -2 gives us that x plus 2. So our h is -2, our k is -3. And what we're going to do now is we're going to look at our a value. And that a value is going to be our slope from that vertex. All right? So it only works if you do not have a b. We don't have a b, we have an a. So that a is going to be our slope. All right? So what that means is we have a slope of 2. So that means we're going to go up from the vertex. We're going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Just keep doing that. And then we're going to go back to the vertex and do the same thing to the left side. Up 2, left 1. Up 2, left 1. So on and so forth. Till you get your big V. Not the best, but it's going to look like that. All right. That point's a little kind of, I went over to the half rather than a full 1. But it's going to look like that. All right. The graph cut off anyway. All right. So we have our absolute value function. And what we're going to do now is we're going to graph this y equals 1. So what we're going to do, we're trying to graph y equals 1. We're going to go to the y-axis, go to where y equals 1 on the y-axis. That's this right here. And once you do that, just draw a line right over it. And that's called the y equals 1 line because every single point on that red line has a y value of 1, right? Right here, that's 0, 1. That's 1, 1, 2, 1, 3, 1, so on and so forth both ways. Every single point on that red line has a y value of 1, so we call it y equals 1. So our solutions, what that's going to be, is going to be the x values of where they intersect. And they intersect right here and right there. So they intersect when x equals 0, or that's that disjunction we talked about, x equals -4. All right? And there's also another way you guys need to know how to write our solutions, and that's going to be something called a solution set. And that's just drawing some squiggly lines, like those fancy brackets, and putting both of your x value solutions in there. So 0, -4. That's saying the solution set is 0 and -4. Those are our solutions to this problem. It doesn't matter if you put it in least to greatest, greatest to least, upside down, whatever. It doesn't really matter. As long as it's in the set, it's okay. All right, for number 2 and number 3, go ahead and try do those yourselves. All right. Remember, just graph both functions on both sides of the equation like they're their own function and see where they intersect. If they intersect, and their intersections are going to be your answers. All right. So pause the video, and I'll post the answer to number 2 in a bit, and we'll talk about it. All right. So I'll go away. All right. Number 2. This is what you should have gotten. For the right side, we have y equals 3. That's the red line. And that's what you get up there, the y equals 3 line that goes right through the vertex. And when we're trying to graph our absolute value function, in this case, our a was -2 with no b. So that means you start at a vertex, and it's negative, we're going down, right? Because if your a is negative, you vertically reflect it, or in other words, you're opening down. So instead of going up and right and up and left, we're going down and left, down and right. So from the vertex, we go down 2, left 1, down 2, right 1, and then you just keep doing the same thing all the way down. All right, if it's negative, you're just opening down. But anyway, what we see here is that our only intersection is right here at the vertex, which has an x value of -2, which gives us our solution set of just -2. And lastly, for number 3, this is what you should have gotten. There's no solution. They never intersected. We're going to graph it the same way. Our a is -1, so we do a slope of 1 going downwards. So that's what your graph should have looked like, more or less. If it's not, rewatch what I did and see what I did, so you can try it again on your own, because you do need to know this for the quiz and the test. All right. We're going to keep going, and now we're going to learn how to solve absolute value equations algebraically. So to solve absolute value equations algebraically, what we need to do is we need to isolate the absolute value first. That's the most important thing. It needs to be isolated. Well, it's not to say it's the most important thing. They're all important. You can't solve any of these steps without any of these absolute values without other steps. But anyway, you have to isolate it. That's important. So isolate it first. Then we're going to set up two separate equations, one positive, one negative. We'll talk about that and see what that means when we go over an example. After we do that, we're going to solve both equations. And then we're going to check both answers when we need to. Luckily for this video, we don't need to. So we'll deal with that in the next video in the next day of notes. All right, so for number one, remember the very first step we need to do is isolate that absolute value function. So minus 2 on both sides to give us the absolute value of 3x equals 6. And I'm actually going to move this down here, give myself some more room. So once we've isolated the absolute value, what we need to do next is we need to take it out of the absolute value function and make two equations out of it. All right. So remember, absolute value, it essentially just turns everything inside of it into a positive, right? So that means we don't know if that 3x is positive or negative, because whatever comes out of it is going to be a positive number no matter what. So we don't know if that 3x is positive or negative. So when we're trying to solve for it, we need to account for both those cases, when 3x is positive and when 3x is negative. So that's why we make two equations to account for both of those scenarios. So let's say when it's positive, we have a positive 3x equals 6. And when 3x is negative, we have a negative 3x equals 6. And something I want to say is pay attention to those parentheses that I put. They are important. In this problem, it's not going to do anything. But in a lot of other problems, it will drastically change the solutions. And it won't make the equation right. And we'll see that in number 2, why those parentheses are important. So it's just a good habit to get into, to just always put those parentheses when you're splitting the absolute value into a positive and to a negative. All right. So we're going to solve the positive side first. We can really just get rid of that positive. It's not doing anything. We just have 3x equals 6, divide by 3, x equals 2. And then for the negative side, we have negative 3x equals 6, divide by negative 3 on both sides, x equals negative 2. And both of these are our two solutions. Like I said, in this case right here, we don't need to check them. So don't worry about that right now. In the next video and in the next day of notes, we'll start to see when we have to and why we have to. But right now, they gave us a number line. So I'm assuming they want us to plot our points. So put negative 2 and 2 on your number line. Make some big dots over those lines. And there we go. That's our solution. We have x equals 2, x equals negative 2 as our solutions. And our number line will look like that. Remember, number lines go from least to greatest. So make sure you put it that way. All right, went up a little too much. There we go. On number 2, we're going to do it the same way. Isolate the absolute value first. So add 2 to both sides. 3 times the absolute value of 4x minus 5 equals 21. Divide by 3. And I'm going to go down here again. We get the absolute value of 4x minus 5 equals 7 after we divide by that 3. All right, so again, we need to make two cases, a positive and a negative. So it's positive. We saw nothing happened, just take it out. 4x minus 5 equals 7. But when it's negative, we need to account that the whole thing inside the absolute value is negative. So whatever 4x minus 5 gives us, that is what's negative. So that's why we put the parentheses and we say negative of 4x minus 5 equals 7. That's why we do it like that. So we're going to go ahead and solve the left side, the positive side first. Add 5. 4x equals 12. X equals 3. That's one solution. And now do the same thing for the negative side. So you see why it's important to put those parentheses is because now we need to distribute out that negative. So we have negative 4x plus 5 equals 7. If you just put negative 4x minus 5, you're not going to get the same answer. You're going to get something completely different. So that's why you have to put those parentheses. It's very important. I don't know what else to say. It's just important. Make sure you put them, all right? So minus 5 on both sides. Negative 4x equals positive 2. We're divided by negative 4 on both sides. Okay, x equals 2 all over negative 4, or x just equals negative 1/2. Just do some math, some algebra, and that's what you get. Those are our two solutions. And again, they do want us to graph it, graph it, but put on a number line. So we go ahead and do that. Negative 2 and 3. I'm sorry, negative 1/2 and 3. So let's say it's negative 1/2. That'll be right there. Our 0 will be somewhere right there. And our 3 will be way out here. But our only solutions are on negative 1/2 and positive 3. All right. Anyway, guys, this is the full video. That's all the notes we wanted to go over for the day. The next slide is just the homework assignments you have. Page 74 to 77, do numbers 12, 13, 15 when B is 1, and 18. And on page 84, do numbers 1 and 3. All right. This is just our homework assignments. Anyway, guys, hopefully this video helped. And just go ahead and do the homework and get some good practice in. All right.